Alright, so today we're gonna cover the Casorati-Weierstrass theorem. So let's take the result. So, so that okay. Okay. Sorry. Okay. So let's see. So if FV has a isolate essential singularity, at a point A, then the image of any punctured neighborhood of A under the function Fz is dense in the plane C. Okay. So if it has an essential singularity at point A, then the image of any punctured neighborhood of A under the function f is dense in the plane C. Alright, so let's begin the proof. Proof. So we prove by contradiction. Okay. So assume that the conclusion is false. Okay, so assume that the conclusion is false. So that is there exists a complex number C and positive number R and have some such that f of z minus c is bigger than or equal to epsilon for z is equal a r. So meaning that yeah, so if the image is non-dense, so dense means that the closure is the entire plane, right? So if the closure is not entire plane, then there's a point that is not the limit point. Because if it's the closure, if the point is not in the closure, then it is not. Yeah, I think it's true. So yeah, so finding z in that. Yeah, so it is there's a neighborhood that actually minus c is bigger than equal to absolute. So now what we do is that now we set so this is like we let g of z to be 1 over fz minus c. So then we have that. So so namely, if you look at this function, so then we have that 1 over modulus of v gv is less than or equal to 1 over epsilon. Okay, yeah, because yeah, okay. And then for z is equal AR. Okay. Yeah. So yeah, namely because this inequality holds, so we take the inverse. Yeah. So that will hold. Yeah. Okay. So anyway, so okay. So anyway, so let's. Okay, so then we know that this G is like bounded, right? So by yeah, so then we can say something about this G. Okay. Okay. So yeah. Okay. So, and since yeah, and GZ is analytic in the counter disk P prime of A center attribute R. Yeah, so namely this GZ is that, and yeah, so basically this F is analytic over yeah, so yeah, so F is analytic over the over D prime AR. Okay, so then we can do that. Okay. Okay. So the thing is that okay. So since GZ is bounded, so by the Riemann theorem, so Riemann simply says if function is analytic and bounded in a function neighborhood of isolated singular point, then the singularity is removable. So since G is bounded, so we know that it can be extended, right? So yeah. Okay, yeah. So YG. Okay. So basically, yeah. So basically, this is saying that the singularity is removable. So we just define the function GZ to be wherever the point yeah, so the isolarity is yeah, so yeah, okay. Yeah. By Riemann theorem. Let's see. Function yeah, over the whole disk. Okay. So okay. So this means that yeah. So this means that so because this G is analytic in this disk, right? So that this G is analytic. So therefore, yeah. So since G is analytic, therefore we know that this guy is holomorphic over, wait, what is the, wait, what's that? Actually equal to C plus 1 over GT is analytic and A. Okay. So if so let's repeat two cases. So if so one case is that the GA is not equal to 0. Okay. So GA is not equal to 0 means that this function R, okay. So this function equal to 1 over C is y. Oh, okay. I see. Okay. It's analytic. Okay. It's analytic at A. Okay. Yeah, because GD is analytic, therefore FD is analytic. Okay. But, okay, so then the second part. Second part is, so if this yeah, so here, yeah, so it is, so here we are saying this, yeah, it is not equal to 0. So if it is equal to 0, then what? So then this D has a root at Z equal to A. Yeah. So if it is equal, yeah. Yeah. So so if it is equal to 0, then GD has a root at Z equal to A. So therefore we have so hence, so because because it has some hence it's reciprocal minus C has a pole at the point A. So namely, so if it has a root A, then it must be a it must be a root of so this is the argument. So contradiction, because it is a pole contradict with the idea that F has a essential singularity, right? So it's a pole. Okay, so contradiction. Okay, so either way, so Z equal to A cannot be an essential singularity.